Today we are talking about decomposing fractions. So if you consider the red piece to be your whole, and we look at this yellow piece, look how it's split up. What fraction of the whole would one yellow piece be? Well, you're probably saying 1/4 because it was split into 4 equal parts, and that represents one of them. Well, this is called a unit fraction. Whenever you just have a 1 in the numerator, like up here, that's a unit fraction because 1 is a unit. So 1 as the numerator means unit fraction. If we had 3 yellow pieces, what fraction would we have? Well, now you're saying that is 3/4 of a whole. 3 equal pieces out of the 4 pieces total that it was broken up to. Therefore, we can do what's called decompose the fraction into the sum of smaller parts. For instance, we could write 3/4 as 2/4 plus 1 more fourth, right? Or if we wanted, I'm just going to make this pen a little skinnier to make it easier, and I'll change colors. We could do a different one where we say 3/4 equals, what would be a different one you could think of? You're thinking 1/4 plus 1/4 plus 1/4. Good. And do you remember what we call each of these? It's a unit fraction because of the 1 in the numerator. So this is written here as the sum of unit fractions. And sometimes in your math journal, it's going to ask you for that. Write it as the sum of unit fractions. Then you need to be mindful that you keep the 1 in the numerator. Okay, so let's try a few more examples. Write an equation to show 4/5 as the sum of unit fractions. And can you think of another way to decompose 4/5 into the sum of 2 or more fractions that have 5 as the denominator? I want you to go ahead and pause the video and try numbers 1 and 2 on your own, and then play back when you're ready to go back over it. So if we look at this together, remember this said sum of unit fractions. So the only acceptable answer here is 4/5 equals 1/5 plus 1/5 plus 1/5, oops, plus 1/5. And notice that I made sure it's an equation. What does an equation have to have? That equal sign. If I had just written 1/5 plus 1/5 and so on, that wouldn't be enough. I had to write 4/5 equals that to really capture all of the math vocabulary. And then another way, there's many possible solutions here. One I thought of was 2/5 plus 2 more fifths. That was one. Maybe you thought of that too. You can give a woohoo if that matched yours. Or another possible one you might have thought of is illustrated down here. If we wanted to get up to 4/5, we could do 1/5 plus 1/5 plus 2/5. Give a woohoo if that was the equation that you came up with. Okay, let's go ahead and try 2 more, 7/12 and 10/10. Again, there are so many possible ways to decompose these fractions into sums of fractions with the same denominator. I'm going to show you one way, and then I want you to try another. So I'm thinking, okay, 7, if I wanted to get 7, I could think of 3 and 4, so I'll put those in my numerator. I'm going to keep my denominator 12, and 7/12 is 3 plus 4/12. Okay, I want you to try another way. See if you can come up with another way to get 7/12. It could have more than 2 fractions in it. Okay, now let's do for 10/10. I'm going to think of 5/10, aka a half, plus 5/10 again. And that would give me 10/10. I want you to pause the video or use this time while I'm talking to come up with another way that you could decompose 10/10 into the sum of fractions with the same denominator. And the last area, oh, I forgot I gave you a real challenge one on here. 120 hundredths. Wow, there are so many possible ways you could decompose this one. Let's try one together. I'm just going to do 20 hundredths plus another 100 hundredths. Can you come up with a different way? Try it on your own. Also, what did you notice about my 100 hundredths? That's the same as one whole, right? So this was actually what we call, and do you remember the term? Improper fraction, or a fraction greater than 1, is what we say. So that brings us to our next point, mixed numbers. So this improper fraction up here could have been converted into a mixed number, right? We could have said this is the same as 1 whole and 20 hundredths, just kind of like we wrote it in the decomposition. So that's what a mixed number is, when it has part whole number and part fraction. So just to practice reading, you say an and between the whole number and the fraction. So I'd read this 1 and 2/8. You practice that. 1 and 2/8. Now let's decompose this mixed number. The first step is we have to think, okay, our whole number, even though it's 1, if we want to give it a denominator of eighths, because that's what we're working at, 1 is the same as, or 1 whole is the same as 8/8, right? And then we just had 2 more eighths, so we could decompose it like that. And once you've decomposed it that way, now you have so many more possibilities. Maybe I think of this 8/8 and I think, oh, that's actually 4/8 plus 4/8 plus, can't forget the 2/8. These equations are the same thing, right? They all are going to, both of those are going to sum to 1 and 2/8. And here you have the illustration of why 1 whole and 8/8 are the same thing. Now, we could have had a mixed number. Let's just do one more. What if it had said, let's see if I can get some space here. So let's say this had said, I'm going to change this guy to, instead of 1 and 2/8, what if it were 2 and 2/8? Well, now when we go to decompose this, 2 wholes, if I want to think how many eighths that is, you know how many eighths that would be? Well, 1 whole was 8/8. 2 wholes, I'll do 2 times 8 in my numerator to get 16/8. And that makes sense too, because fractions are just another way of saying division. And 16 divided by 8 would be 2. So this is the same as 16/8 plus 2 more eighths. Enjoy all the unlimited possibilities, or not necessarily unlimited, but the many, many possibilities as you decompose fractions today.